Okay, let's unpack this. We're diving deep today into something that, well, it feels pretty futuristic, doesn't it?
It really does.
The quantum internet. But the sources we've been reviewing show it's already starting to take shape.
And it's interesting because it goes way beyond just, faster speeds or better security, although those are definitely factors.
Right.
The material we've looked at really pushes us to consider the sheer scale of potential here, the kind of transformative effects it could have across so many different sectors.
And also the challenges, the real hurdles involved.
Absolutely. The hurdles, too. It's not straightforward.
So our goal here is really to kind of cut through maybe some of the hype and understand what building this technology truly involves, what doors it might open, and, well, the complexities we need to navigate to get there.
It's all laid out in the research we've gathered.
Exactly. So digging into this material, one of the first big things that jumps out is how the quantum internet isn't just about communication in the way we usually think of it.
Yeah, it's more about creating this specific network designed from the ground up to link quantum computers together.
Okay, so connecting quantum computers, why is that the killer app, so to speak?
Well, what's really fascinating there is that the power isn't just in, moving bits faster. It's about enabling these incredibly powerful quantum processors, these machines that can do calculations impossible for today's supercomputers to actually work together.
Globally.
Potentially globally, yes. Imagine linking them up across the world.
And the sources give some specific examples of the kinds of problems this kind of linked-up quantum power could tackle, right? Problems that are just, well, beyond us right now.
Exactly. Things like modeling extremely complex biological systems, think proteins folding, drug interactions at a level of detail we just can't currently achieve. Or optimizing these huge, sprawling global supply chains with an efficiency that's completely unprecedented.
And if you think about the impact of those examples, modeling biology could revolutionize medicine. Optimizing supply chains affects, well, everything. Food, goods, disaster relief.
The potential scale is enormous. If we can actually realize that kind of distributed quantum computing power, it could genuinely touch billions of lives.
Speaking of impacting lives, the sources describe the potential effect on healthcare as nothing short of revolutionary.
They really do. There's this picture painted of hospitals, research centers, sharing patient data across the globe.
Okay, but data sharing raises red flags for security, obviously.
But that's the key point in the material. It's sharing it in real time, but using quantum encryption. This relies on the actual physics of quantum mechanics to secure the data.
Making it fundamentally tamper-proof.
Essentially, yes.
Yeah.
The idea is that this could basically eliminate the fear of data breaches for incredibly sensitive medical records. That's a constant worry today.
That security piece is huge. But how does secure data sharing lead to the faster diagnoses and personalized treatments the sources mention?
It's what you can do with that secure, accessible data. With instant access to these massive anonymized global data sets, you can run quantum algorithms on them.
Algorithms suited for that kind of complex data crunching.
Exactly. They could analyze this information almost instantly. The material gives a really powerful example, accelerating drug discovery.
How so?
By simulating molecular interactions with unprecedented accuracy. Think about simulating exactly how a potential drug molecule interacts with the target protein in the body before you even start the expensive, slow lab work.
Wow. That could cut down development time significantly.
Potentially by years, it could really change the game for finding new medicines.
Okay, that's healthcare. What about finance? Another area where security and speed are absolutely critical. The sources point to big benefits there, too.
Oh, absolutely. The financial sector is always fighting increasingly sophisticated cyber threats, right?
Constantly.
So the material talks about implementing tamper-proof quantum cryptographic systems across these global financial networks.
And again, this isn't just stronger encryption, it's fundamentally different.
Right. The physics means any attempt to eavesdrop actually changes the quantum state, instantly alerting the sender and receiver. It's inherently secure against certain types of attacks.
And that improved security feeds directly into things like fraud detection.
Precisely. Making fraud detection nearly instantaneous across these incredibly complex, high-volume global transaction networks. Getting that level of security and efficiency worldwide, that's a massive step up.
So it's not just about protecting data or money. Scientific collaboration seems like another area ripe for transformation. How would this change how scientists work together?
Well, think about the bottlenecks in science today. Often it's about sharing enormous data sets, running huge simulations that require distributed computing power, collaborating effectively across continents.
Yeah, the sources mention powering these core scientific processes, data sharing, simulations, even publishing findings faster.
And it gives examples like international teams tackling, say, climate change models, which are incredibly complex, or huge astrophysical simulations.
Projects generating just mountains of data.
Exabitus, yeah. And coordinating complex calculations among researchers who might be spread all over the planet. The quantum internet could allow near-instant, secure sharing of quantum states or results.
And enable distributed quantum computations across labs.
Exactly. Letting teams share results, run parts of a simulation together, iterate much faster. It could genuinely speed up the pace of discovery and enable completely new kinds of collaborative science that just aren't feasible now.
So we've hit computing, healthcare, finance, science. But the sources also stress this technology goes beyond just communication as we know it. What other, maybe unexpected areas might see applications?
Yeah, this is where it gets even more speculative but interesting. Logistics, for example. Companies could use real-time quantum data processing, perhaps, for complex optimization problems to manage operations with incredible dynamism, reacting instantly to changing conditions on the ground.
And entertainment. There was a mention of virtual reality becoming much more immersive.
Right. Think about the sheer data load needed for truly photorealistic interactive VR worlds in real time. Quantum networking could potentially handle those massive data streams and the complex simultaneous simulations needed for environments that feel, well, completely real.
Indistinguishable from reality almost.
That's the potential, yeah.
And education too. The idea of global quantum classrooms.
Allowing real-time, genuinely collaborative learning across continents. Imagine students in different countries working together on a complex quantum experiment simulation, perhaps.
That could really break down geographical barriers to high-level education and research resources, making expertise much more accessible globally.
Far more than current online platforms allow, potentially.
Okay, that's a really exciting, almost dizzying glimpse of the potential the sources lay out. But they're also very clear this isn't going to be easy. It's not like flipping a switch.
Not at all. There are really significant challenges and some complex ethical questions we need to tackle head-on, as the material points out quite strongly.
Practical issues, societal issues.
Both. Like accessibility. Who actually gets to use this? Who controls this incredibly powerful new infrastructure?
Right. Is it going to widen the gap between, say, developed and developing nations? Or could it somehow be a bridge?
That's a core question raised. And then there's the sheer practical hurdle. The massive, massive cost of building and maintaining these incredibly complex quantum networks.
Which naturally leads to the concern that access and control could end up limited to, a privileged few certain nations, maybe huge corporations.
Exactly. And the sources stress how important it is to grapple with these issues of equitable access and control now while the technology is still being developed, not try to patch it up later when disparities are already baked in.
That makes sense. So, given all this potential and all these serious challenges, where the sources say we actually are on this journey? What does the roadmap look like?
We're definitely in the very early stages. The material describes governments, private companies actively experimenting. They're testing small-scale pilot networks.
Crucial first steps, but small steps.
Very much so. Far from a fully linked global system.
There are specific examples mentioned, right? Like a U.S. project connecting research institutions.
Yes, connecting major labs. And China's work launching quantum satellites for secure communication tests over long distances.
So people are working on the fundamental building blocks.
Absolutely. These are vital stepping stones proving you can generate entanglement, distribute it, maintain coherence over distances. But the material is really clear. This is a marathon, not a sprint.
And the timeline. What are experts predicting based on the current pace? Any consensus in the material?
The general view presented is that it could realistically take decades, plural, potentially several decades before we see anything resembling a truly operational global quantum internet actually emerge.
Decades. Okay, so stepping back, looking at everything we've pulled from these sources, the quantum internet is presented as this incredibly powerful, almost visionary idea. It could lead to a future that's much more interconnected, secure, innovative.
It genuinely holds the promise of enabling solutions to problems that seem completely intractable today, and fundamentally transforming so many parts of society: medicine, finance, science.
But And it's a big, but the material leaves us with a really strong message. As we stand here at the beginning of this journey, it's really up to us, researchers, policymakers, technologists, the public, to make sure this incredibly powerful tool gets built and rolled out in a way that actually fosters progress, promotes equity, enhances collaboration.
And doesn't end up creating new divides or just concentrating power in fewer hands.
Yes.
It's not just a tech challenge, it's very much a societal one.
Which brings us to a final thought, something for you, our listener, to really mull over. Given this predicted timeline, decades before it's fully realized, and these significant concerns raised in the material about the huge costs and the potential for unequal access, what specific actions or policies do you think are the most crucial ones to focus on right now? What needs to happen today to help ensure that this future technology genuinely benefits everyone, everywhere, instead of just widening the gaps we already